接下来将是我们 Luca 会为大家带来下一场的演讲。Developing evolutionary AWS Lambda with Hexagonal architecture。Luca 他本身是 AWS 的 Principal Software Solution Architect， 也是 Orion 的作者，也是一个非常经验非常丰富的国际演讲者。好，那我们就欢迎我们的 Luca。Hello
Luca。Hello。
Hello, nice to meet you.
Likewise.
Yeah. Okay. So now it's your time, so you can start at any time.
Perfect. Fantastic. Thank you very much for the introduction. And sorry a bit for my voice. I have a bit of cold, so it would be a bit weird, my voice, but don't worry. I will do my best that you will be able to enjoy the talk. Today I'm going to talk about AWS Lambda, but specifically how to modularize your code in order to have let's say a system that would be able to follow the drifts that the business is looking for. Because in reality, every business is evolving and is changing direction, and we have some ways as architects and developers that will allow us to follow their direction and improve and evolve our architecture following the right business direction. My name is Luca Mezzalira. I'm a principal solution architect at AWS. I'm an international speaker and an O'Reilly author. So let's start with defining what evolutionary architectures are. And directly from the book Building Evolutionary Architecture, that if you didn't read, trust me, is a really great book. You can see that evolutionary architecture supports guided and incremental changes. And I think here, the key part is the incremental changes, because more often than not, when we have like new features that are coming or there are new requests from the business, they are quite chunky. So they start to say, I would like to connect your system with this third party and then evolve the computation, adding new functionalities and anything. What you need to think about every time is trying to break down those, let's say, complex requests in smaller units that are deliverable. And that's why evolutionary architecture can really help us to achieve that. So I think everyone at least once have to deal with the three-tier software architecture. Three-tier software architecture is composed by three layers. The first one is a presentation layer. You have then the application layer where all the business logic lives. And then you have a data layer where basically you store your data. But the problem when you deal with this kind of architecture that is still valid, I see a lot of, let's say, that's still a lot of implementation with three-tier architecture nowadays. The problem is that in the long run, what usually happens is there is a leak of domain between the data layer and presentation layer towards the application layer. What it means is basically sometimes when you need to implement a feature and you are under pressure or time constraints, you start to take this code and start to, let's say, create some tech debt. The problem is more often than not, it's difficult then to remember about the tech debt or to, let's say, fix the tech debt. And sooner rather than later, the application layer becomes obliterated of information that shouldn't live in that specific layer. The other thing that I have experienced firsthand was moving some workloads to AWS Lambda. So imagine that you have, for instance, your container living on AWS ECS, or you have your application running in a virtual machine, in this case, EC2, and you want to move everything to Lambda. The complexity, if the code is not well structured, is extracting a portion of a domain and move to the Lambda. Now, this, despite it could, let's say, seem a simple problem to solve, it results that is not, especially when you don't plan upfront on creating some code that is modular enough for being decoupled, and then you will be able to easily move between different compute services. The third point that I want to make is more often than not, when you're looking for example on lambdas, or maybe you have some lambdas that are written similar to this one, you find this kind of code. And usually what you have is inside your Lambda handler, you have like all this code that contains basically the retrieval of the request from the body, in this case of a post request. And then you have like submit candidate P, that is basically the function in the middle of this image, and candidate info. So those two basically functions, what they do is submit candidate P is communicating with a database. Instead, candidate info is containing information around the domain, so what we want to store inside the database. But as you can see here, there is a mix and match of incoming requests, parsing, validation, and then you have like integration with infrastructure and so on and so forth. If we want to evolve this kind of code, it becomes complicated, mainly because we need then to test every single bit end to end to make sure that we didn't introduce any bug. And that is a very, let's say, challenging problem, because when you are working in large system, if you have multiple of those implementation, you risk that you jeopardize your velocity and throughput, because you basically are living in a code that is very tightly coupled together. So Hexagonal architecture is trying to solve that. Alistair Cockburn, that is the creator of Hexagonal architecture, but also co-signed the Agile Manifesto. So it's a person that really give a lot to the software community, created Hexagonal architecture with one thing in mind, trying to find a way to decouple the business logic from the environment where it's running. And that basically provides some nice side effects. The first one is that you can drive your application in different ways. It could be like a batch script. It could be a unit test. It could be, let's say, a request from a service. But because you modularize very well your code, you don't risk to pollute the business logic in a way that then became unflexible, and therefore you need to spend a lot of time to evolve it. The other thing that I want to focus is understanding deeply how Hexagonal architecture works. So let's take a look to the anatomy of an Hexagonal architecture. So the first, if you want, layer or hexagon in this case is the domain logic. The domain logic is basically what you want to achieve inside your AWS Lambda. The beauty of applying Hexagonal architecture on Lambda is that because Lambda by design is not, let's say, a very complex environment, so you have like a small amount of logic. If you encapsulate very well your domain logic, it became easier to test and evolve it without too many problems. The second layer is the ports. And ports are basically the entry point for the external world towards the domain logic, and also are the way how the domain logic is interacting with the external world. And finally, you have adapters. Adapters, as the name suggests, is taken from the idea of the adapter pattern. That basically is a way that two different contracts are communicating together. The role of the adapters is basically becoming your anti-corruption layer between the external world and your business logic, and is also translating what is coming from the external world towards the internal world. The communication between domain logic and adapters is happening always through ports. This architecture is also called ports and adapter. So you can hear Hexagonal architecture or can hear ports and adapter, they mean the same thing. The interesting part of this is the ports could be, it depends from the language that they are using, it could be just an interface, and therefore an adapter is implementing an interface for communicating with the domain logic, or it could be like in the example that we are going to see, a function. I'm going to use Node.js with ES6, so JavaScript and not TypeScript, but with typed language like Java or C# or TypeScript, you can use interfaces. The other part that you need to be aware on the Hexagonal architecture is that you have primary actors. The primary actors are the ones that are communicating with your AWS Lambda, in this case, inside your Hexagonal architecture. what they are. It could be another microservice. It could be a client. It could be a message inside the queue, because the Lambda can be called synchronously or asynchronously. And then you can have secondary actors that basically are the actors that are used by our code for, I don't know, for instance, retrieving information from a database, consuming a service, a third-party service, or adding a message in a queue. So those are basically the key point on how you're going to structure your hexagonal architecture. That obviously is valid for AWS Lambda, but it could be valid also with a container or with the virtual machine. Bear in mind, currently the focus of this talk will be on Lambda, because I think these architectures specifically can really shine inside the serverless paradigm. The benefit and drawbacks. So benefit is the business logic is agnostic to the outside world. And that is absolutely great, because it means that we can evolve it and change it without affecting the rest of the code. It's independent from external service. Therefore, for the business logic, it doesn't matter if we're using a SQL database or no SQL database. What it matters for the business logic is that it's going to request some information to a repository, and then the adapter encapsulate all the logic for interacting with that repository. And that allows you to really evolve your code in a way that it's better for everyone. Then it's easier to test and test in isolation, especially. And we will see more in this talk. And finally, is reducing the technical debt. The fact that you spend a bit of time upfront defining those boundaries and those modules will allow you to run faster in the long run. At the same time, on the pitfalls or drawbacks, you need to spend more time thinking on building multiple layers, because you need to create adapters, ports, and business logic. And in the original implementation defined by Alistair Cockburn, there weren't too many references on how to structure your business logic. That is not necessarily a negative thing, but it means that you have an opportunity for, let's say, use your knowledge and your style for encapsulating better the code inside your business logic. So if by now you're thinking, okay, why an hexagon? Why not another shape? Alistair Cockburn is providing also the answer for that. The hexagon is not the meaning of how many sides we need in a shape, but it's just a good way to represent the complexity that a specific service could interact with. Before, with just rectangles, we didn't have enough space for drawing all the interaction that the service could be exposed to. And nowadays with microservices, this is becoming even more important because you may have multiple interaction as a primary or secondary actors. So I prepared a demo on this, and what we are going to see is this. It's a very simple demo, but provides you the idea of what we can really do with this approach. So first of all, you have an API gateway that is exposing an API. The API is basically every time you call this REST API, you trigger an AWS Lambda. It's called stock converter, and as the name suggests, what it expects is a stock ID. And when you receive the stock ID, it's going to retrieve the value of the stock ID from the stocks table, that is a DynamoDB table. And then it's going to call a third-party service where it is going to retrieve real-time all the currencies. And then when it has those two piece informations, the business logic is going to apply the currencies to the stock value and return back the value of the stock in multiple currencies. That's basically what we're going to see. And when we see in slow motion how the interaction would work, so first of all, you will have an HTTP request. The adapter will pick the HTTP request, and through the port is going to communicate with the business logic, passing the stock ID. Then the business logic as a first thing is going to call a port and saying to the port, please retrieve this stock ID. And the port knows that has to communicate with an adapter. Then the adapter is communicating with DynamoDB because it is encapsulating inside it all the information related to DynamoDB. And then the business logic triggers another action that is calling through an adapter, through a port, another adapter that is communicating with the currency service, that is a third-party service. And then it returns everything. So let's go back to our IDE and let's try to see what we have here. Okay, so this is the structure of my project. As you can see here, I have a folder for adapters, domain, and ports. Usually, it depends how you want to structure. You can potentially divide also these parts per domain and have like one business domain that contains port adapters and business logic. In my opinion, because we are working with Lambda, we are already reducing the scope of the domain. So in theory, you should be able to structure the code with just adapters, domain, and ports, but it's completely up to you how you want to do that. If we see how the code works based on the logic that I just explained, this is the entry point of our Lambda. Okay, so we have like literally not much here, because what we have is the Lambda that is retrieving the stock ID from the URL, and then is passing this information to this adapter that is called that has a function called getStockRequest. GetStockRequest, once again, in this case is a primary adapter because it's coming from the primary actor. And what it does is just calling, it doesn't have to do validation on anything, it's just calling a function for inside a port. And when it receives the response, it will wrap the final, let's say, response to the client. If we go inside then the port, as I said before, but it's important to iterate, is as simple as a function in JavaScript. If you have TypeScript or any other type language, you can use an interface. So the port, basically what it does in this case, is exposing a function and is communicating with a business logic. Why we're doing this? Because in this case, now we have the adapter that is completely decoupled from the business logic. Therefore, we can evolve those two entities as we want, without risking to, let's say, having side effects that are bubbling between different layers. As long as the contract will remain the same, we are in a good shape. So in the business logic, once again, here we have all the currencies that I want to use. So in this case is American dollars, Canadian dollars, Australian dollars. But the important thing is that I have other two actions to do. First, I call this repository port that will communicate with a repository, in this case, DynamoDB, through the adapter for retrieving the stock ID. When I retrieve the stock ID, I will then call the currencies, therefore a third-party service for doing so, and then I will apply the logic that I explained before for, let's say, applying the currency to the original stock value. Great. So let's go for the repository. So the repository is a port, and as a port, it just has a function that calls an adapter. The adapter is getStockValue. This is a secondary adapter because it's calling, is handled basically by our AWS function. And here, as you can see, what we have is all the information related on how to retrieve a specific item from the database. If I want to change the schema, if I want to change the way how I'm querying the database, or the way how I'm, I don't know, writing data in the database in a hypothetical thing, the only thing that I need to change is this part here. And that is one of the benefits of working with this approach. Now, if we go back to our business logic, the other interesting part is what we're going to do with the currencies. And the currencies has this port that's called get currency data, and then it goes to retrieve the currencies. Here we have a point-to-point communication with a third-party service, and that's it. So we retrieve the information, we send back to the business logic, and business logic knows how to do. By now, you understand that the business logic doesn't know who requested this information. It could be API gateway, it could be unit test. It doesn't matter for the business logic. And it doesn't care even if it's communicating with a SQL or NoSQL database, or where is the endpoint that we are retrieving the information. Therefore, we encapsulated very well the business logic and can evolve as we prefer. Now, let's play a game. let's think about a new scenario. You deploy this AWS Lambda in production, and your service starts to get a lot of traction. So people are extremely interested into that. And what happens then is that you basically start to see some errors coming out from your Lambda, because the third-party service is not capable to cope up with the traffic, the requests per second that you have from your service. You need to figure out a way to solve that. Obviously, it's a third-party service, so you cannot say, listen, can you increase by, I don't know, 10x the amount of requests that they have, because they have, let's say, their own architecture and their own things to handle. Therefore, usually you have a limited amount of requests that you can have. Okay, so the other alternative is that you handle on your side. So in this case, what we can do, instead of using this adapter, I created a new adapter that is called currency converter with cache. And here, as you can see, I have exactly the same signature, so the same function, the same contract. But what I have added here is Elastic Cache with Redis. That is a service available in AWS for using a managed version of Redis cluster. And the beauty of this approach is that basically I'm implementing a cache inside my logic. So here the logic would be, first thing first, check inside Redis if I stored any currency, and if I do, return back to the client without making any call to the third-party service. And to a certain extent, this is great, because that means I'm offloading dramatically all the traffic that is going to the third-party service because I'm using the cache. If the cache is evicted, is empty, I have the possibility to call the third-party service, and then I immediately store the information retrieved from the third-party service inside Redis, and I set an eviction policy of 20 seconds. After 20 seconds, automatically, Redis will evict the cache, and you can go ahead with, let's say, querying again the third-party service for retrieving fresh data. This approach scales pretty well, because as you can imagine, if you have 10 lambdas that are, let's say, querying the database simultaneously, then you go with these 10 lambdas, you are going to hit the vast majority of the time Redis more than the third-party service. So that is great. Okay, so we have seen how to structure the code in Node.js and how it works. Now, another example that I want to add on this scenario game. So imagine now that instead of having a Lambda, the team that was working on this was starting from a container, and therefore Docker container in this case. So in this case, this is the code that I need to do. As you can see here, I have the same folders with the same files, okay, nothing different. So I copy and paste those inside this new application. I have a different, obviously, entry point, because this is my web server in Node called Fastify. It's a well-known framework in Node.js. And the interesting part is this: the entry point is exactly the same. What it means, though, it means that basically, imagine that you have a CRUD application where you are creating, updating, writing, and reading, and deleting elements inside the database. I will have, obviously, multiple of those methods. So if we structure the code in a modular fashion, we can extract portion of the code and move to a Lambda without any problem. And that is the power of this approach. We can also move between compute services very easily, because we modularize the code in a way that would allow us to have this flexibility to evolve our code based on the business needs. Okay, so let's go back to the slides and let's start to think about other use cases, because those are some of them, but there are more. So the first one is testing in isolation. As I said before, now the business logic is well encapsulated. And that means potentially you can have a faster feedback loop when you're writing code. Imagine that you are writing your code and you have your business logic that is well isolated. You can even separate how you're running your code in a way that when you connect to a database, unless you are often changing schema, that is not going to happen very often, that code will be rock solid, so you don't need to test. But the business logic would evolve. And therefore, What you can do is dividing the test for the adapters and the business logic in your development environment, and then testing more often the business logic or the part that is evolving more, and therefore having a faster turnaround on the rest, and then doing more extensive tests when you are about to open a pull request or whatever. But this really speed up the way how you are doing testing. The cache aside pattern is the one that we have seen before. So we implemented Redis cache, and it's very similar. So you have a service that is hitting your Lambda, and then the Lambda is communicating with the database. In order to offload, or a third-party service, in order to offload the request, because maybe some of the queries are always the same, you can add a cache. And depends obviously from database to database that you're going to use. If you're using Dynamo, you can use DAX, that is another service that is, let's say, fully managed and allows you to have a cache layer in front of Dynamo. But if you want, you can use Elastic Cache with Redis, and it's completely up to you, or MemoryDB, that is a new service that we launched very recently. The other thing is, imagine that you want to change the trigger, so the way how your application works. So instead of having an API gateway that is calling the Lambda function, now you want to have an asynchronous model where the API gateway is storing the request directly to SQS, so a queue, and then the Lambda is triggered in batches. So it takes like few elements inside the queue, start to process them, and then behind the scene, the client is starting to have a request, a polling mechanism, or a socket for understanding when the computation is accomplished. So those kind of things are easy to implement, because in this case, the only change that you're going to make, as long as the computation remains the same, is at the primary adapter. So you basically change the adapter in a way that instead of receiving the request from API gateway, has to extract the data from SQS. And that is great, because it means that basically we don't have to change anything on our business logic. Another scenario is service migration. So imagine that you have a Lambda that's communicating with a self-managed Mongo database. And at some point you realize that you spend too much time on maintaining this database and you want to move to a managed database version. So in this case, it could be AWS DocumentDB that is, let's say, powering MongoDB behind the scene. The beauty of this approach is that, once again, you're going to change just the adapters. For the business logic, doesn't care if it's MongoDB or DocumentDB. And also, you can apply certain migration patterns that you wouldn't be able to do so. So despite you, obviously, when you do a migration of database, you need to find a way to migrate the data. But then on the business logic side, you can use, for instance, a branch by abstraction pattern that basically is allowing you to run those two things in parallel, and maybe for a certain period of time, just to make sure that all the data are synchronized properly, you check on MongoDB the responses that are coming from DocumentDB, and then when you are confident, you just move ahead. But that is a really great use case. The other thing is web application modernization. So imagine that you have your monolithic architecture and you start to divide that by different subdomains. And then those domains, usually in software architecture, as Sam Newman described multiple times, this is called a modular monolith, when you have a monolithic code base that is divided by subdomains. What you can do is basically preparing yourself for migrating to microservices. And that is going to help, because when you divide with hexagonal architecture your code in multiple subdomains, then it's easy to extract a portion in multiple microservices. And the same thing is going to happen when we do from microservices to Lambda. The interesting approach here for me is this one. So the fact that you have a microservice with multiple, obviously, endpoints that are running there, you can extract some of them in Lambdas based on the volumetric that you're going to receive. So for instance, if your microservice has a lot of reads, but not many writes, and many delete and update, what you could do potentially as a first step is instead of going with 4 lambdas, one per REST verb or HTTP verb, you are going to have one for read that has a different scale pattern compared to the others, and one for the other 3 actions. And then when you see that there is a real need for, let's say, moving away and from maintaining these 3 let's say other HTTP verb in the same Lambda, you can slowly but steady migrating, but you are gaining immediately the serverless benefit because you move away from having a managed container. Then finally, hybrid strategies. And that is an interesting one, right? Because sometimes you have some workloads that require your code to run in two environments, maybe on-prem and on the cloud. And an example is if you have your hexagonal architecture, what you could do potentially is running your AWS Lambda in AWS, and then have the same business logic running on Knative. Knative is a Kubernetes offering for serverless that could run everywhere, to be honest. The beauty of this approach is that you write once the business logic, and then you basically start to spread the so the test is just once, and you are really making sure that everything is working. The only thing that you are going to change probably are the adapters. And as long as you maintain the same contract, the only effort that you have is maintaining the adapters in AWS and in Knative. That is, in my opinion, absolutely fantastic. Finally, there is one real, let's say, niche and esoteric, if you want, architecture that I'm quite interested on, but it's still early days. It's called path-elite architecture. The concept of path-elite architecture is basically having the possibility to work with microservices at the development time, but deploy in smaller units when you go on the cloud in this case. So what it means is that I'm developing a microservice and another team is developing another one. And because they're in the same domain, I can merge them at compile time and send all together inside a unique EC2 instance or whatever. This is still, let's say, early days, and there are quite a few researches around that. But it's something that I wanted to add just to give you an idea that where also hexagonal architecture can shine. I've seen an implementation that is using a library, Node.js library called microlib, that what it does is using these and even going further where you can reload at runtime your code directly inside your Hexagon. That is quite interesting, obviously still early days. So don't take this tomorrow in production, but definitely keep an eye on it. So obviously hexagonal architecture started, so was let's say released in 2005. So big time ago. And since then, there were some evolution. So the first one is this onion architecture that what it does is solving the problem that we were describing before, trying to create a more structured and opinionated business logic. And the same was it happened in 2012, where Uncle Bob, let's say, introduced the clean architecture that is similar to the Onion one, but with different, let's say, entities and constructs. The interesting part here for me is if we're talking about, let's say, monolithic code base, I see the need of structuring better the business logic. Totally, I can see that. On a Lambda, in theory, if you structure properly your Lambdas and you're not going to have a very complex Lambdas, using just hexagonal architecture, as I've shown you during this session, I think would be more than enough, because otherwise you start to go too granular. And, you know, talking with a customer, he was telling me, we went to the clean architecture route for microservices, and it was a proliferation of files that at the end was difficult to manage in the long run. And I totally agree. So you need to find the right balance and the right trade-off, despite, yes, there are some other more structured architectures, but I believe that hexagonal architecture, as I showed you, it should be enough for your serverless workloads. So now the question probably after this, this session is this the definitive architecture that AWS encourage for developing Lambda? The answer is it depends. As a good architect, I couldn't say yes or no, because it really depends from the context. Architecture is always based on trade-offs. It doesn't exist the right or wrong. What the only thing that exists is that your context has some requirements, and based on the requirements, you take a decision. Now, what I see really shining this architecture is when, for instance, you have a workload that has to evolve during the time. Imagine, for instance, that you are developing a software as a service, or you have an internal product that you need to maintain for years and years and years. Definitely investing a bit of time on structuring your code with hexagonal architecture can really help. On the other side, if you have, for instance, a project that should stay online for, I don't know, a couple of months, because maybe it's an event, starting with hexagonal architecture probably is an overkill. Same when you have like a service that is not doing much. It's maybe a service that is just, I don't know, calling a third party, or basically is a proxy between two elements. Starting with hexagonal architecture probably is an overkill. But there are, let's say, situations where it can really shine. For me, the important thing that for me should be your main takeaway is try to understand deeply your context. Find what are the characteristics of your architecture, and then based on that, take the decision if hexagonal architecture could help you on your serverless workload or not. So just to wrap up, so we have seen that we have a strong separation of concern with the hexagonal architecture. Then we have seen that the infrastructure is fully decoupled from the business logic. So we can evolve both in parallel and potentially with, let's say, different people, or even you can evolve taking different direction without any problem. Hexagonal architecture is easy to test thanks to the two characteristics that I mentioned before. And finally, there are many use cases that are simplified when we use hexagonal architecture. Therefore, if for any given reason you know that some of the use cases that I mentioned are going to happen, fear not, because you will be able to cover them. I gather in these slides that I will share later on quite a few links. You can find the demo that I showed you on GitHub. And you have also, I wrote an article based on this example and what I described that is available in the compute blog of AWS. And you can read basically what I described during this talk. And then you have a bunch of other links, like the original article on hexagonal architecture, the onion architecture, clean architecture, and so on. That's it for me. Thank you very much. I'm more than happy to jump on some questions. And if you want to contact me because later on you have other questions or anything, that is my email. So feel free to contact me anytime. I respond to everyone. So thank you very much.
Okay, thanks, Luke. Okay, wait.
Okay, thanks, Luca. Wow, that's very informational and knowledgeable present. Okay, so the next one, we'll go to the Q&A session. If you haven't asked the question yet, please go to the Slido and post your question. And you can opt for your favorite one so that we can see that more clearly. I will choose that one. Okay, so let me see. Okay, Luca, could you see the Slido
Yes.
on my screen?
Totally.
Okay, cool. Yeah, great. So let me choose the first one. Okay, the first one is, does the hexagonal architecture must go with AWS Lambda? The way it decouples ports and adapters from business logic seems to fit in on-premise service as well. Okay, you can go.
Yeah, totally. So the hexagonal architecture, it doesn't work only with Lambda. It works with containers. It works with any type of code. It's an architecture pattern, right? I think hexagonal architecture was well discussed for long time inside the community, and it's not, let's say, a novel thing, but I thought that currently I didn't see many talking about hexagonal architecture properly on AWS Lambda. And I think with AWS Lambda, where more often than not, because it's a small entity, we tend to just write everything inside the handler, is a good pattern for helping the development of serverless, let's say, architectures, creating a well-structured mechanism that at least is well known and also is easy to implement. So definitely you can run on premise, you can run on container, you can run wherever you want.
Okay, thank you. And yeah, let's actually this is my first time to hear we can mix hexagonal architecture with Lambda. Okay, that's very interesting, and we can see lots more potentials for AWS Lambda. Okay, next one. Okay, so is the currency converter service thread safe? I'm a serverless TFC member. I know the answer, but I guess attendees want to know that. Okay, smile face.
I believe so. So I don't believe it would be not safe. So yes, I think the answer is yes.
Yeah, cool. That's a sweet, short and comfort. And yeah, good answer. The next one. Can we take hexagonal architecture as the idea of clean architecture in cloud-based service?
Yeah, totally. You can use this architecture for Lambda, for whatever. The other two architectures that I mentioned, like Onion and Clean, I mentioned them mainly because sometimes when you go online and you start to research around the hexagonal architecture, they bubble up very often, and people start to say, oh, this is an hexagonal architecture. And it's true, technically speaking, they are hexagonal architecture. However, it's not the original implementation, are more structured version of the hexagonal architecture that are taking all the characteristics of hexagonal architecture and then adding on top of that a more structured business logic.
Yeah, I agree that those architectures share some common characteristics. Yeah. Okay, next one. So someone is very curious about what. Could you explain more about the petal-less architecture? And explain more characteristics.
Yeah, so the name Petalit is coming from one of our colleagues in AWS, Adrian Cockcroft, that was the chief architect in Netflix. He migrated basically the Netflix architecture towards cloud and microservices, and now is working in AWS on the sustainability part. So his idea basically is trying to decouple try to reduce, let's say, the complexity on the infrastructure, on maintaining infrastructure, but maintaining the same flexibility that you can have with microservices at development time. And the idea is pretty interesting if you think about that, because compute and resources are becoming extremely cheap. So if we are capable to say, okay, instead of having a proliferation of microservices all over my accounts, I start to have less of them, more, if you want, infrastructure-wise macroservices. And then although I have a very granular approach on the way how I'm developing, and then basically the infrastructure part is completely decoupled by the development phase. So I don't map one team to one microservice or one API to one microservice, whatever it is. I map a domain to a bunch of microservices. I have the benefit of using microservices, therefore distributed teams that are empowered to make changes atomically. But on the other side, I have less to maintain on the infrastructure because there are less things that could go wrong. Everything, maybe a specific domain could live inside the same machine, and therefore the communication is even not affected by latency and other things. So the concept is pretty interesting. I think it may break some other ideas that in the community are well known by now, but it's definitely an interesting architecture, and I'm keeping an eye on it because I want to see how it's going to evolve.
Yeah, thank you. That's cool. Okay, I think we still have some time. Okay, so let me go through the next question. Cool. So next one is, when we apply Lambda to make the it make the microservice? What things will meet problem and the risk?
Yeah, so at the end, Lambda is, if you think about that, is running inside a container. So if you have already a containerized microservice, let's say you shouldn't have too many troubles. Obviously, it depends what you're doing inside the microservice. If you're doing some special things, like using specific, I don't know, extensions or anything, you need to apply carefully them on Lambda, wherever it's totally doable, but that is not a problem. The beauty of Lambda is usually that you try to split up in a modular fashion what you have in a microservice. So in the example that I was making before, having a CRUD operation where you are decoupling basically the read from the write operation inside your system, you can have, for instance, 2 lambdas. You can even have more if you want to scale in a different fashion. The risk, I would say, on top of my head, I would say that the main risk that you may have is some patterns that are not manageable by you. So for instance, if you say, I know upfront that I'm going to have, I don't know, 5 million of requests per second on a microservice, then you can say, okay, I prepare everything upfront in my containers, and I warm up everything. I add more machine than needed, and so on and so forth. With Lambda, you have a service, you have a feature that allows you to have a pre-warm of your Lambda, but then you are living inside the constraint basically provided by the service, because it's fully managed service of a compute part, and therefore you can increase the amount of Lambda you can have per account, but definitely there are some quotas that you need to be aware, and you need to, when you design your workload, be very aware to understand how your traffic pattern should be implemented inside the serverless solution. I think that is the main thing, but what you can do in a microservice, you can do also in a serverless application.
Yes, thank you. Yeah, I agree that however, no matter what kind of techniques you are using, make sure you understand its limits and its ability. Yeah. Okay. Next one, the live demo is really cool and well explained. I'm curious how to explain the advantage of the architecture that is easy to understand for business people. Yeah, that's quite a big challenge.
Yeah, thanks for the praise on the demo. Thanks for that. So I think there are a few points. So the first one would be the possibility to evolve their needs faster, the less introduction of production bugs that already are a big advantage, and the fact that you can really drift the direction of a system quickly, because yes, there is an initial investment, but if in the code that you have seen, I really have small amount of code that working as a solo developer or even in a team, it became extremely easy to atomically say, okay, we need to make this feature. You take care about the adapter. I take care about the business logic. So you can really parallelize the work in a nice way. And if you are disciplined enough on maintaining the structure during the life cycle of the project, you would be able really to follow and expand the need of the things. And probably the third thing could be innovation. So if you want to try one thing quickly, you just try that, and you, let's say, wrap in a way inside your code that is modular enough that you can immediately test it. And then if it doesn't work, you can remove at the same speed. So you have innovation, you have faster turnaround on new features, and you have less bugs in production. I think just these 3 characteristics should be enough for business people.
Yeah, I agree that I think the only thing the business people only care about is, could you deliver your products more frequently, more faster, and more safely? Yeah, that's all we concern about. Cool. The final one is, could you list some main aspects that make you choose hexagonal architecture from others?
Yes. So the main choice for me is when I have a project that I need to maintain in the long run. So, for instance, imagine that you want to run a quick POC, just to a proof of concept, just to make sure that your idea is working. That probably I wouldn't go with an hexagonal architecture. But then when you want to really implement your code and you are working on a product that has to maintain, you are going to maintain for 6 months, 1 year, whatever, is where usually I will look into it, especially for serverless, because in other architectures, so if you for other more monolithic code bases, like for container, whatever, there are plenty of architectures out there that you can use. The beauty of this is that you can really test in isolation certain parts, and the fact that you can let's say structure your code in a very modular fashion. So for me, in a Lambda, if already by design, it shouldn't have too much scope inside the Lambda, so it's very easy to create. But if we add also hexagonal architecture, evolving that became easier. And so for me, the rule of thumb would be: is it code that I have to throw away after a while, or is it the code that I am not going to use for long term, or is this very, very small action that I need to do inside my Lambda? Probably I won't use hexagonal architecture. For the rest of the use cases, yes, let's say it's a bit of more investment, but it's not definitely that it's going to take twice the time for writing a Lambda.
Yeah, I agree. I think every investment has its own risk, and you can always start small. But if you want to go farther, maybe you can consider other things like hexagonal architecture. And if you want to have a more scalability, and you want to have more, to want to involve your models quickly, maybe you can consider Lambda and hexagonal architecture. Okay, so thank you, Luca, again, and very happy to have you here.